Hello, everyone. My name is Nina Grasnik. I'm co-lead of the Farm to Regional Scale Integration Network, which is part of the Global Research Alliance on Agricultural Greenhouse Gases, the GRA. And the GRA is a network of 64 member countries, which aims on fostering research on reducing greenhouse gas emission intensity in the agricultural production system, among other things. And you can also find more information if you access the Global Research Alliance homepage. And with this, I warmly welcome you to the first webinar of the Farm to Regional Scale Integration Network on the topic Economic Analysis of Climate Change in Agriculture, Marginal Abatement Costs. But before we start the webinar, I would like to inform you that this webinar will be recorded and the recording will be publicly available at the GRA homepage afterwards. And also the presentation slides of our three speakers will be available there. And before we start now, just a few instructions on WebEx, because you probably haven't used it before. So the most important feature here is this smiley reactions, where when you click on it, you get this pop-up window, and there you can raise your hand if you have questions later on. And also after this webinar, we will provide a 15-minute deep dive session with our speakers, and you can access the breakout rooms in this deep dive session if you click on this button here, participants, and then you will see the 3 breakout rooms. And here you can also use the chat function to put your question, and we will forward it to the speakers later. Yeah, and with this, I hand over to my colleague, Klaus Deblitz, who will give a short introduction of the Farm to Regional Scale Integration Network. Thanks.
Thanks a lot, Nina, and welcome everybody. Pleased to see more than 30 participants by now. Yeah, this is, I think, the 3rd session we are running here in this Farm to Regional Scale Integration Network. I think the network itself has been presented before, so I will not waste too much time with this. I think we agreed in this network to develop this stepwise. We have focus on the farm level, and we also agreed, I think, that we should provide a little bit more space than before to the economics of greenhouse gas mitigation and adaptation. And so my name is Klaus Deblitz. I'm co-chairing this network with Jelto Zimmer, who is I'm the livestock guy. Jelto is the crop guy, and Nina basically does all the work so far. Thank you for that. And we also have a new face here, which is who is Katrin Ageten. She's a PhD student with our institute, and she's actually doing a PhD with a global approach on mitigation strategies on farms using a case study approach, which is basically using methods, tools, etc., from our AgriBenchmark network. And her thesis actually forms also the basis for the flagship project that we have submitted to the GRA, and which is basically in the process of development. And that's basically all I have to say at the moment. So I hand back to Nina again. Thank you.
Yeah, thank you, Klaus. And before we now start with the presentations, I would just like to give you a quick overview of our past and future activities, and all the links you see here will be also posted in the chat, so you can have them available for later information. So in May, we had our kickoff meeting, and yeah, the recording and the meeting report you can find here at the GRA homepage. We also created a LinkedIn group, which you're very warmly invited to join. And also the webinar series, which is starting today, will continue on November 16th by a webinar that was organized by our co-lead Jelto Zimmer, and information for this will follow next week. We also started to create a project database of our network members to see on what kind of research projects everyone is working on right now. And you are also warmly invited to include your research project by filling out this survey here. And last but not least, we started a working group to develop a GRA flagship project proposal, which will also, among other things, do some marginal abatement cost analysis. So this webinar today fits perfectly to discussions we had previously in this working group. And you're also very warmly invited to join this working group. If you're interested, just send me an email to this email address provided below here. And also if you have any other questions regarding the network activities. Yeah, and with regard to time, I will now give a quick overview of the agenda today and introduce the speakers. So Gary Lanigan from Teagasc in Ireland will kick off the presentation round by focusing on the Irish agriculture. Afterwards, Titus Abdini from Wageningen University and Research in the Netherlands will continue by a case study from Costa Rica. And John Antle, last but not least, from Oregon State University in the US, will conclude the presentation round by giving a more broader overview on marginal abatement cost curves and sustainable development. And then we will have 20 minutes for a panel discussion, and we will close the official webinar then, but offer you the option to stay 15 minutes longer and join all 3 speakers in breakout rooms to discuss further questions. Yeah, and with this, I want to invite Gary to share his presentation, and yeah, the floor is yours.
Okay, thanks a lot, Nina. I think, here we go. I'd like to thank Nina and Klaus for inviting me today to give this talk. So without much further ado, I shall start off with the presentation. And this first slide is basically showing the context in which we undertook conducting marginal abatement cost curve analyses. We came out with this study about three or 4 years ago, and really it was in the context of the fact that our emissions, we did use the FAPRI Ireland's model to look at what our projected emissions were going to be over the next commitment period from 2021 to 2030, and really to see where agriculture was going and to what extent agriculture, forestry and other land use and bioenergy could contribute to emissions reduction in Ireland. And I suppose this has moved on quite a bit since then. So the Irish government at the moment currently have a climate action bill that is currently being formulated, and the envelope of where agriculture may or may not be going in terms of emissions reduction is, our target is probably going to be somewhere around about a 21 to 30% reduction by 2030. So this was the context in which we were doing this analysis piece. But not only do we have an issue in agricultural emissions, we also have issues around land use and land use change. So our LULUCF profile, is very different to other countries in that we have quite a small forestry sector and quite a large amount of grassland. In fact, we have a large amount of grassland on peatlands, and they emit a lot of CO2. So LULUCF, unlike other parts of Europe, LULUCF is in fact a source of CO2, a net source, not a net sink. And again, by 2030, we're probably looking at having to reduce those emissions by just over 50%. By 2030 down to about 2.7 megatons, and that's in the context where our emissions and removals from LULUCF, our emissions are actually without mitigation, will probably increase up to 2030. So as part of that, we ended up producing actually 3 separate abatement cost curves, one for what we would classically call agricultural emissions, that is methane and nitrous oxide emissions, another land use change abatement cost curve, and then finally a bioenergy piece. So in terms of estimating marginal abatement, the first thing we did was we looked at, well, what is the biophysical potential, i.e. the maximum amount of abatement that can be can be achieved by a measure. And then talking to our advisors and talking to experts in the area, we looked at the uptake rates of the measures for each individual measure to see what the likely uptake might be across the country and between different farm typologies, be it, say, a dairy farm, beef farm, tillage farm. We looked at the costs of the measures, of course, and they, of course, have to include all the CAPEX and OPEX costs, including the cost of a farmer's time, for example. So a lot of our beef farmers, for example, are only part-time farmers. So costing in their time as an actual economic cost was vital, and then also the cost of extension services. And then the other issue that we saw with some of the measures is how a measure is actually implemented can be important. So, for example, if we were to get every farmer in Ireland to buy a low emission slurry spreading unit, that would be far more expensive than getting a smaller subset of agricultural contractors to buy that piece of equipment and then to contract out their services. So how you actually implement a policy can be very, very important. So without much further ado, this was the agricultural MAC that we generated. And what you can see that the two different colors, the pale blue color is what we term the efficiency measures. That's the measures that reduce the carbon footprint of a product, but not necessarily the absolute emissions. And then we have the what we would term the mainly nitrogen-based emission measures, such as changing fertilizer type, improving nitrogen use efficiency on farm, that actually will result in a decrease in the absolute amount of emissions coming from a farm. And basically what we found was that we could mitigate around about 1.8 megatons, or roughly about 17% of agricultural emissions using these agricultural measures. But the key thing to note here is that the measures in theory don't cost a whole lot, but secondly, there is no single silver bullet, okay? All of the measures contribute a small amount, but you need a suite, a mosaic of measures to arrive at the maximum rate of reduction. So if we look at the measures that can be reflected in the inventories, changing the addition of clover, for example, into a sward is reflected in the inventory via a reduction in the amount of nitrogen sold. Changing your fertilizer type to a protected urea product that has less N2O emissions associated with it. Again, that can be reflected in the inventory. Slurry amendments that reduce slurry pH, again, can be reflected. And low emission slurry spreading, again, can be reflected in the inventories quite easily by the sale of the number of units. One thing that we did note, however, was that if you only look at these measures through a greenhouse gas prism, you don't necessarily get the range of co-benefits that individual measures might bring. And I'll point out again here to this low emission slurry spreading, be it injection or trailing hose or trailing shoe. So in Ireland and the UK, slurry in the main is still splash plate and broadcast applied, and moving to low emission slurry spreading, it reduces greenhouse gases because you have a higher fertilizer replacement value on your slurry, but it also reduces ammonia, of course. But from a greenhouse gas prism, if we look at this, it looks expensive and it looks like it's not mitigating a whole lot. However, if we then look at an ammonia marginal abatement cost curve, what we see is this low emission slurry spreading has an enormous amount of ammonia abatement, and it's actually relatively cheap from a euro per kilo of ammonia nitrogen abated. So again, this is a case in point that if you're looking at measures, you have to look at measures not only from necessarily a greenhouse gas point of view or a nitrous oxide point of view, but you need to look at those measures in the round. What we do note with our ammonia measures, though, unlike our greenhouse gas measures, is that two measures actually deliver about 80% of the mitigation. And they are low emission slurry spreading and the use of protected urea. And in this case, it's the use of protected urea instead of straight urea to reduce ammonia emissions. In the case of our greenhouse gas mitigation, it's the use of protected urea in place of ammonium nitrate to stop N2O emissions. Okay, so again, that's a subtle but very vital difference. The other thing we looked at then was land use emissions, and we see here that the big beast in terms of economically effective emissions reduction from the land use sector is going to be afforestation and forestry management. But one thing that you do need to remember over time is that agriculture, unlike many of the other sectors of the economy, the emission factors tend to vary temporally in time and also spatially. Okay, and no more so than with the land use and land use change emission and land use factors. And what we've seen since we did this piece of work in 2018 was that low planting rate has hit our forestry sequestration, so that's reduced it a bit. We've had higher deforestation than we previously thought, and that's inputted on our forecasts. And the other thing that's changed is the emission factors actually associated with forestry, and particularly forestry on organic soils. That's high carbon soils. Those emissions have actually gone up. So that's actually eaten into our forestry sink. So in fact, the amount of mitigation we have coming from the land use sector is, we think, we project over the next few years is far less than we thought it would be. About 800,000 tonnes per annum. So over a 10-year period, that's an 8 million hole in our carbon budget that we didn't expect to see. And this is always the problem. And again, the reason why marginal abatement cost curves probably need to be updated quite regularly is because you're not dealing in an area where you've got stable emission factors that don't change.
Gary, you have 1 minute left.
Yeah, nearly finished there, Nina. And really, I suppose, if we look down at the bioenergy piece, here we see that estimates are very uncertain. While the emission factors in terms of the amount of CO2 that you can displace by not burning fossil fuels and burning bioenergy instead, while that is quite static, the actual uptake is far more uncertain. Okay, and again, what we see is that a lot of that mitigation that we forecast mainly again related to the forestry side of the house. So again, when we look at these marginal abatement cost curves, be it from a land use basis, or from an agricultural basis, or for a bioenergy basis, the first thing we do see is that afforestation and forestry is going to have to be quite a large part of our mitigation moving forward on the whole land use side of things. And then again, it's not static. So we have a new project, in fact, that will be looking at new measures and formulating a new MAC curve over the next 2 to 3 years. And not only do the economics change, particularly of the bioenergy measures, but you've got new feed additives, for example, coming on stream all the time. And you've got different land uses, be it agroforestry or in the use of carbonation and biochar that you can use. But you've got new measures coming on board all the time. But what we do find is that biophysical agricultural mitigation, no matter which way we look at it, will probably never go beyond about 20 to 25% of mitigation for the sector. And really, when you're talking about making deeper cuts, you're talking about changes in terms of land use, in terms of farm diversification, and also then the use of bioenergy, be it anaerobic digestion or biomethane, or the use of wood residue to displace fossil fuel emissions. So really moving forward, as we move into a climate where we're trying to get carbon neutrality for the sector, broadening out our definition of agriculture is going to become more important, and we'll have to encompass the whole circular economy, biorefining and bioenergy piece. Okay, thank you very much.
Yeah, thank you, Gary, for this presentation. I think with regard to time, I would propose to directly jump into the next presentation by Titus and invite every participant to write your questions in the chat so we can take them up in the panel discussion. And also, Gary, maybe can already answer them also in written form. So, Titus, the floor is yours.
Thank you, Nina. I would like to share my screen. Can you see my screen?
Yes, not yet in presentation mode.
Yeah. Is it okay now?
And now we see the notes.
Okay. Well, I will redo it again. It was not like this before.
Yes, perfect.
Okay, perfect. I hope it's fine. Hello, everyone. Thank you for having me, Nina and colleagues. My name is Titis Abdini. I am here to share our work entitled Marginal Abatement Cost Curve for Latin American Dairy Production using case study in Costa Rica. This study is one of the outputs from Suscorida project. It stands for Sustainable Futures for Costa Rican Dairy Sector. This is the project from the collaboration between partners in the UK and Costa Rica as listed in this slide. And my participation in this project is part of the Cliffgrad Fellowships program that is organized by Global Research Alliance. My presentation will be started from introduction, and at the end, I would like to end with giving some take-home messages from our study. I would like to begin with the significance of dairy sector in Costa Rica. Dairy production has important role to meet high annual consumption of Costa Ricans. Besides, it also contributes to value added for export of agricultural products. But dairy sector also contributes to greenhouse gas emissions. And this is a particular challenge for Costa Rican government that aim for carbon neutral economy. Another pressure on dairy farms also appears because of the free trade agreement with the neighboring countries that will eliminate import tariff of dairy products by 2025. Hence, dairy farms must be competitive in the future as a sector to supply the demand of milk for Costa Rican populations. And also at the same time, it's not supposed to adding more environmental pressures. To do so, we need to identify the mitigation measures at farm level. There are already mitigation measures identified by some studies, but the cost of the mitigation measures are still unknown for a specific typology, for a specific farming system in Costa Rica. So the objective of our study is to develop MAC as a tool to assess feasibility of mitigation measures for Costa Rican dairy sector. We also expect that our study will be a pioneer for Latin American countries to use MAC as a tool to present the feasibility of mitigation measures. We collected data from almost 100 dairy farms that are classified into 5 typologies. Those farms are a member of Dos Pinos Dairy Cooperative, the largest dairy cooperative in Costa Rica. The data collection is conducted from 2018 up to 2019 by Cartier. This data was used to conduct life cycle assessment to assess greenhouse gas emissions. We present this assessment into CO2 equivalent per kilogram of milk. Simultaneously, we also conducted workshops to identify mitigation measures. This workshop was attended by multi-stakeholders. representatives from governments, experts, also farmers were there to attend the workshop and identify what are the measures that we included. And last step, we calculated, of course, abatement cost, which is the cost to implement a specific measure per unit of reduced greenhouse gas emissions. As I mentioned before, we had 96 farms in total, and it was categorized into 5 typologies according to the different purpose of farming, either dual purpose farming or specialized dairy farms. Also based on the farming system, whether it's extensive or intensive dairy farms, and the location of the dairy farms in lowlands or uplands in Costa Rica. This is the mitigation measures that we identified. There are 3 groups of mitigation measures. We classified into efficiency measures, technical measures, and pasture measures. We use this abbreviation to present our result later. But to give an overview, we included improvement in animal health, genetic improvement, increasing the amount of the concentrate, and also some technologies to be implemented at farm level, such as anaerobic digestion, installing ventilation or sprinkler to reduce heat stress, the technology to apply precision feeding, and also introducing silvopastoral system. There are measures specifically for pasture management, such as improve grass variety, introducing legume, and nutrient management plan. Moving forward to the results of the study, this graph showed the results of our LCA that compare between the reference and the greenhouse gas emissions from different measures from different typologies. So we can see here that all measures have potential to abate greenhouse gas emissions per unit of milk. And it shows over here that silvopastoral systems has the highest potential, and on the contrary, precision feeding, this one has the lowest potential of greenhouse gas abatement. And this is the overview of MAC for dairy farms in Costa Rica, including 5 typologies, and different colors show the different measures that we identified. So as we can see that the x-axis show the abatement of the greenhouse gas emissions. So we can see that the width of the bar shows how much reduction of the greenhouse gas emissions, and the height of the bar shows the cost, whether it's expensive or cheaper measures. And I will go through the detail of these MAC results and the trends from these curves in the next slide. Okay, so we can see that there are bars above and below zero value of x-axis. This bar shows that the measures are cheaper to be implemented to reduce greenhouse gas emissions per unit of milk. And some measures consistently reduce the cost across typologies, such as animal health, increasing the amount of the concentrate, and implementation of nutrient management plan. But there are also some measures that are relatively expensive across the measures. These are improvement in genetic, so basically changing breeds, introducing legume, anaerobic digestions, and silvopastoral system. The costs of introducing legume and silvopastoral are relatively expensive for the establishment. So to change the current pasture system into the new pasture management using legume and silvopastoral is relatively expensive, while the anaerobic digestion is also expensive, although we also we were informed that this technology might be cheaper in the future. And beside the trend across the typologies, we can see that each measure can behave differently for each typologies. So our study highlighted the relevance to assess mitigation strategies in a context-specific way. In this case, the typologies of dairy farms in Costa Rica. And we recommend further analysis to understand the consequences of expanding the system boundary for our assessment of greenhouse gas emissions or another environmental impact, and the cost of implementation of the different measures. This expansion of the system boundary, for example, can be the combination between milk production system and beef production system. This study also didn't observe the interaction between measures, although Gary also mentioned before that to have the optimized mitigation results, some measures can be implemented together, so it can add up the effect of the abated greenhouse gas emissions. Okay, thank you for listening, and I'll be happy to answer the questions.
Yeah, thank you so much, Titus, for giving these insights into the dairy sector in Costa Rica. And again, I would like to wait for the questions after our last presentation, which will be now John Antler. So the floor is yours.
Okay, thank you. Hopefully this will work. Just give me a second to switch modes here.
Yes, looks great.
Okay, great. Thank you. Good morning, afternoon, evening, as may be the case for everyone. I am just going to have a few words to say about marginal abatement cost curves and sustainable development. And like Nina said in the introduction, maybe take a little bit broader perspective. And I guess I'm going to describe it as a perhaps historical perspective at first, you might say. I also just wanted to say thanks for the invitation, and particularly from the AgMIP team. I'm one of the members of the AgMIP leadership group, and we're very happy to be associated with the GRA and its various activities. And this particular one is of interest to me because as part of AgMIP, as well as my own work, this farm to regional issue and modeling across scales, climate impact, adaptation, mitigation is a big interest of mine personally as well. So forgive me for this term. You're probably familiar with this expression, deja vu all over again. If not, it comes from a famous baseball manager, the New York Yankees, a long time ago. Hopefully the relevance of it will be clear as I proceed. And what I wanted to do was just step back into the 1990s when a lot of this research really began. I distinctly recall my old colleague Keith Postjan, who some of you may know as a soil carbon modeler, first coming to me and saying, John, we should, there's this idea of carbon markets and things like that, and we should do something on this. And I said, oh, you're crazy. That can't possibly work. Anyway, he persuaded me that it was possible. And many people, of course, starting really, I would say in the first decade of the 2000s, estimating, call them carbon supply curves or marginal abatement cost curves, various methodologies using econometric models, simulation models, and of course now here in this presentation we had two nice examples of this methodology that I would describe maybe as a kind of economic engineering approach of taking the information and constructing these marginal abatement cost curves. What happened then, of course, was that we really, from the climate policy perspective, we were not very successful. And Kyoto, of course, kind of fell apart in the U.S. You know, when Barack Obama was first elected in 2008, many of us thought we might actually finally have a national policy in the U.S. That failed. And a lot of us, I think, broadly speaking, many in the climate policy community turned to adaptation, thinking, well, if we're not going to mitigate, we'd better start worrying about adaptation. And since then, of course, kind of putting mitigation and adaptation together as it probably should have been from the beginning. Then along came Paris in 2015, and I distinctly recall being at this conference that was held in Oxford in September 2016, and I believe someone else actually made the point, a well-known person working in this field, I won't identify, but made the statement, well, time to dust off all those papers we wrote 10 or 15 years ago. And I think that was really true, because at that point we had done a lot of work in that earlier period that really had not been picked up and used yet by the policy community. And of course, now we're hoping that it will be as things proceed right now with the current COP and so forth. So perhaps the answer, and the point of that conference was meeting the challenges of the Paris Agreement. So perhaps that means we needed to go back and dust off those old studies, but probably update them and improve them. Of course, a lot of science had progressed since then, and the methodology has been refined, again, like these two studies have just illustrated here today. The point I wanted to pick up on, though, is that in the meantime, we also really made important advances in thinking about what we mean by sustainable development. And of course, this idea of the sustainable development goals was really sort of solidified through the UN. And of course, many of these are relevant to agriculture, but of course, it's not all about climate. And one of the points that has struck me for some time in a lot of the conversations around climate and climate policy is that it's very climate centric. And I think that plays an important role in understanding some of these challenges we faced in going forward with climate policy. You know, how can we, and so it's a great challenge to try to address all of these sustainable development goals. And there are many interactions, synergies, trade-offs, we might say. And I think that's an important contribution that we economists have to play in helping us sort out all of these interesting and important interactions. So just to illustrate this point briefly, I wanted to just talk about a small study that I did with my colleague, Roberto Valdivia, who's also associated with Oregon State University, and we've been working together on these things for a long time. And this is a small case study we did some years ago, actually about 7 or 8 years ago, related to a project known as the East Africa Dairy Development Project that was funded by the Gates Foundation and managed by Heifer International, and also involved the International Livestock Research Institute. And this map shows the sites where they had data from Kenya. It ultimately extended out into some other parts of East Africa. And they were looking to double dairy income for 500,000 small farms, a typical modest Gates project, over 10 years using genetics management and improving markets for dairy. What we did was, at that time, was to do an analysis using a model we developed we call the trade-off analysis model. And we had these indicators. We had economic indicators, farm income, poverty rates. We had water use and methane emissions in the environmental dimension. And in the social dimension, we had women's control of assets and income, and also infant milk consumption to represent child nutrition. And we did a set of simulations to represent a range of the technologies, the way it was implemented, and the associated adoption rates. And you can see from this graphic that we generated a lot of information, and I don't expect you all to study this figure here in the next 30 seconds and make sense out of it, so I'll summarize for you. But what it shows is, I think the important message here is the complexity of these systems, and across these various dimensions of sustainability, and it shows certain synergies associated, for example, higher income with this improved dairy system, lower poverty, better nutrition, but increased water use, higher methane emissions, and decreased share of women's control over assets in these households. So the point I want to make here, of course, is simply that if we were only, we could have done this analysis as we used to do, just looking at our greenhouse gas emissions relationships. But from a sustainable development perspective, of course, we want to be concerned about these sort of three broad dimensions of sustainability and perhaps an even larger number of indicators. And so then, it kind of raises this question of how we interpret these economic these sort of narrow, you might say narrowly economic analyses, when in fact many people are concerned about these broader issues. And that might help us understand perhaps, I think a lot of the debate over greenhouse gas mitigation and the concerns, along with the other legitimate concerns about, for example, permanence of a lot of the emissions reductions. I did, previously a lot of work on soil carbon sequestration, for example. And we know there's important and legitimate concerns about the permanence, for example, of soil carbon sequestration. Well, how to go forward? So I say the limit of MAC, but what I really mean is economic approaches more generally that are very kind of climate centric, and this, challenge of broadening our perspective. I just wanted to conclude by mentioning a project that AgMIP is starting to work on now, where the approach is to think about mitigation and adaptation, of course, together, and the associated co-benefits, potentially synergies, as well as trade-offs associated with the proposed changes in production systems, as a way to try to broaden the perspective. And then finally, a small bit of shameless self-promotion for those of you who find this approach of trade-offs and synergies interesting, and if you want to learn more about it, I published a book with a former student of mine, Srabashi Ray, last year on sustainable agricultural development, where we talk about this approach a lot. And if you email me at this my email address, I'd be happy to share an electronic version with you for your personal use. So with that, I will wrap up, Nina, and turn it back over to you.
Yeah, thank you, John, and thank you for raising these questions in the end, which I think are also great bridge to our panel discussion now, which will be moderated by Klaus. So thanks to all speakers from my side again.
Try to
over to
share
Klaus.
my screen.
Yeah, thanks a lot, Tifis, Gary, and John, for these very insightful presentations from different angles and perspectives. While John is trying to close his screen there, and making all of us visible again.
Sorry,
No worries, no worries.
I am getting an error message all of a sudden, and I'm not able to release it, unfortunately.
Also, you cannot click recover work and restart more PowerPoint. I would tick that off and then say okay, if you can do that. I'm not sure.
Yeah.
If you go to the very top of your screen, there should be the orange button.
Yeah,
where you
I'm
can
doing
close.
that, and it's not responding because I've got a Microsoft error reporting thing.
On an Apple computer, yeah, that's always the problem. They don't
Yeah.
really go together very nicely.
Yeah,
Anyway, look,
sorry about
I
that.
just thought because of the time and because we have a deep dive session with the three presenters here, I would rather than answering a lot of questions, specific questions to these presentations, I would rather like to go to what our director Nina created here in terms of questions to the presenters. And I have I took some notes here as well. The one question was, what are the limitations of agricultural abatement cost curves, marginal abatement cost curves? I think we heard already some, and how can they be addressed? Second question was, how can the results be used to provide evidence-based policy advice? Or what are policy implications that can be drawn? And what are the existing research gaps related? And I think limits were already mentioned somehow. I think it was mentioned that these abatement cost curves have to be updated probably regularly because environment is changing. Yeah, I mean, just think about the droughts we had in Germany, and now we have forestry rather as a carbon emitter, not as a carbon sink. We also know that there is always variation between farms, especially when we do case studies, so how to make sure that this is more or less representative. And in terms of policy advice, I found quite interesting what Gary said. So unless you find a silver bullet for methane, especially in grass-based systems like you have in Ireland, you will probably not get much further. But you also mentioned forestry and slurry technology is something you can tell policymakers to take care of. And I also found interesting what John said, to take a broader view. I mean, that's basically maybe addressing more the research gaps, and you are already going into that direction about co-benefits / synergies, or let's say disadvantages like trade-offs, and to look for a more comprehensive view, looking at interactions as well. So that was what I took as a starting point to these three questions. So who of the three presenters would like to start? I mean, Titus, I would of course give you ladies first, the first opportunity here to react. But if you would like one of the gentlemen to do first, feel free to say so.
I'm okay to kick off the discussion.
Great.
Yeah, the very first questions about the limitation, I would say there are a lot of assumptions behind our calculations, and this is still unknown. For example, the assumption related to the greenhouse gas emissions calculation, or the assumptions about the production of a certain, the changes in production, like milk productions in because of the certain measures, we rely upon many assumptions, and those assumptions is derived based on our communication with the experts or available literatures. So the knowledge gap is there, that the research is needed, whether it's experimental research or developing a very dynamic and robust model to simulate the mitigation measures. That's an opportunity to expand the research into that direction, to understand really what will happen with the measures. And another question is how to provide the policymakers for the options, I think.
Yeah, how the results of these analysis can be used to provide evidence-based policy advice.
Yeah, this is very relevant for Costa Rica, especially if the government, let's say they have NAMA livestock, which are an action plan that includes several strategies to reduce greenhouse gas emissions from livestock sector. And within that plan, they have many actions listed. For example, the main strategy is still including silvopastoral system and pasture management. So this study actually gives an overview that how feasible it is or how economically benefit those actions for the farmers, because those actions so far are very top-down approach that the government included because it has successful stories long time back, but maybe it's not very affordable anymore for the farmers, and it's supposed to be supported by another policy. Those kind of policy actions from the government is needed to, because after seeing the economic analysis of these measures at farm level. So that's the benefit for the policymaker to see, do they really list a good action plans, or do they need to focus on a certain action plans which is affordable for the farmers?
Very nice. Thank you very much, Titis, for this. I would like to ask John to comment on these questions.
Sure, thanks. One thought I have is that one important aspect of all of this analysis is dealing with the tremendous heterogeneity that we see in agriculture. And I think Gary mentioned that as part of his presentation. As you look at those marginal abatement cost curves, every one of those segments has a distribution around it, of course. And so as we look across a diverse population of farms or farm operations, then we really see this range of those values. So that's one important consideration that, again, just the data demands to really quantify that and to understand the reality that's out there is a huge challenge. So we have a huge data challenge in doing a better job, and then like we've mentioned, also keeping that information current, because the world is a very dynamic place. The other point I think real challenge we need to face is this linking across scales. Because many of these relationships are very site specific, we do need to account for all of that spatial heterogeneity as well as temporal variations. But then to be policy relevant, yeah, we need to have this bigger picture that the policy people are looking for. That, we really haven't solved that problem yet, I would say, for the modeling community. Many people are working on it right now. But really, how do we make this linkage from a global and national, you might say, more market perspective of the economic relationships that are involved, how that translates down to the site-specific relationships, and then conversely feeds back, and how to understand all of that, either in an equilibrium sense or in a disequilibrium or dynamic sense, really, is currently beyond our modeling capabilities. So I think that's a huge challenge that we need to address and do a better job on.
Thanks a lot, John. And I would like to hear Gary's points here as well.
Yeah, I'd agree with everything that John actually said there. I mean, when we did our piece of work, it was to address a policy question. That policy question was, how much could agriculture reduce emissions? So by its very nature, it was a very top-down approach. And that question of scale is a huge issue. A MAC curve at a national scale is not a production system, for example, that you can implement on farm A or farm B. And as John said, that I would think that the difference in if you were to look at two dairy farms, for example, in Ireland, you can get wider distributions probably in terms of the emissions from those farms than you can between a farm in Ireland and a farm in the US. There's such a huge range of heterogeneity within a country, never mind between countries. And I suppose the issue that you really get down to when you model at a national scale, you can probably smooth out a lot of the differences that are there. When you're getting down to individual farms or farm typologies and maybe individual regions, the little differences suddenly become important, like soil type and climate and things like that. So, and again, I suppose the other thing is again, when we're asked by policymakers to perform these analyses, where again, it's very much in the prism of climate change or something else. But again, if you don't look at the impact of a measure in the round on, say, maybe water quality as well, or on air pollution emissions, ammonia, for example, you may not be getting the holistic impact of a measure. So again, looking at the co-benefits and also maybe some of the antagonisms is something that needs to be explored a bit more.
Yeah, thanks a lot, Gary. I would like to ask Katrin or others if they would have found some replies to these answers in the chat, rather than let's say more questions. Yeah, but I just want to say that it looks like what we are trying to do here is under an enormous time pressure. When we think about climate change, we try to find the squaring of the cycle by looking at many things at the same time, and at the same time we have to look at the economics of our research. Like we are all aware, and you know that we are also working with these case studies, so we are very good in terms of production systems. But then we are being asked what happens on the more aggregated level, and the same and the reverse thing happens basically to approaches that start on a higher aggregated level and try to go down to the ground. So I think I don't have an answer, but my feeling is that we just have to prioritize let's say measures and probably related cost where we know that, I mean, the methane conclusion from you, Gary, was quite instructive for this. If we don't change that, then we can do a lot of other things somewhere else if we don't manage to address this issue.
I think that one of the challenges in agriculture is that there are no very quick wins, particularly within livestock-based agriculture. You're talking about getting farmers to implement a range of different things, and that's not necessarily an easy sell, to get them to implement, a range of different things. And the other criticism I hear often as well is that if you look at what all of us presented, you see that there's those win-win solutions that are below the y-axis. And the question I'm always asked, well, if they're so win-win, why is nobody using them?
Exactly. I can confirm this with our analysis we did in South America, and we have some answers to this, but maybe it goes too far now. Yeah, but that's really clear. Okay, is there anything coming from the others, from the other participants here, or from the chat to these questions? I couldn't follow the chat in parallel. I just saw there was something coming up.
I mean, there's more questions, but not directly related, I think.
Okay,
maybe
so I'm
a question from Nick. Some GHG mitigation measures will take longer to implement than others. In economics, the calculation of net present value is used to account for the lower value of delayed income. To what extent is net present value taken into account in MEC methods?
Anyone who would like to reply to this of our three experts here?
I think it's measure specific. So particularly for things like the bioenergy measures, such as biomethane or biogas, that's where, yes, you need to use MPV in that calculation. So it's going to be measure specific. But yes, I agree, you have to use it sometimes.
And I'll just say quickly, another aspect of this that we struggled with quite a bit in some of the work I've been involved with is how on the one hand there's the issue of whether the changes in the system involve sort of variable costs or fixed costs, that sort of thing, and how you represent that in an appropriate way when you look at the costs of changing the system and that sort of thing. And that probably does relate a bit to that criticism of, oh, gee, if in fact as I describe it, the opportunity costs are really negative, why aren't people doing this stuff? But the other side of it is the whole greenhouse gas accounting and the temporal perspective that's appropriate for that does also complicate this a lot. And for example, in the soil carbon story, where really understanding where you're at in terms of the system status, and is it in equilibrium or is it disequilibrium, and so there are a lot of also temporal complexities from that perspective as well. I guess the last quick comment I'll make, that has come on the screen recently in the debate in the U.S. over climate policy, that, as you probably know, is going on pretty strongly right now. There's been a lot of pushback from the agriculture industry, for example, livestock, where they're saying, and I think with some justification, look, you guys are accusing us, of being bad actors in beef production, that sort of thing, but the accounting is incomplete and you're not doing, the big picture. And if you really did a more complete job, across not only the livestock industry but other sectors, we wouldn't look like just the bad guys that you're making us out to be. So I think that all just gets to the point that doing this well and doing it in a comprehensive way really, when we really get serious about the policy, then people start to look carefully at what we're doing and they take it seriously, and we really have to be credible, or else they pull the rug out from underneath the scientific community. And so that really, is coming home to roost, I think, in some of the discussions in the US now.
Okay, that potentially opens a much wider debate, John, and I think we might think about having this at a later stage, but I
Sure.
suggest, because of the time that we basically don't start this now here. I think it was we have a very really tight schedule today. I would just like to basically invite people to join the deep dive session, which will be opened soon, so where you can basically talk directly to one of our three presenters. But I would also like to announce that it was mentioned soil carbon. It was I would like to announce the next webinar, which takes place on the 16th of November, so in a good 2 weeks time. And that's about carbon farming with no-till and straw incorporation, a reality check. Jelto Zimmer, who is here, is basically hosting this event with some colleagues. Jelto, I don't know if you would like to mention a few words about this event.
Yeah, thanks for letting me know. Yeah, the key idea really is to double check the prevailing assumption that both no-till as well as straw incorporation can be major measures to reduce greenhouse gases from crop production. The issue is that there is recent research on this topic that the previous assumption on those measures might be misleading, at least in a lot of cases, probably not globally, but in a lot of cases. And we invited one colleague from the USDA, Mark Liebig, and a colleague from Thunen to present on their research and findings from other colleagues on these two topics.
Yeah, thanks a lot, Jelto. So you already provided part of the answer to these questions, so we are looking forward to look into that more deeply.